So in this video, I am going to show you the steps for hypothesis test for a single proportion. First, state the null hypothesis and the alternative hypothesis. So the null hypothesis is something that already the carbon value, which is usually given, equals to some number. A alternative hypothesis is either greater than that number or less than that number or not equals to. It's something that we want to prove. It's what we want to prove. Okay, second step is check the central limit theorem. They have independence, randomization, success, and the failure condition, which is n times p has to be greater than or equal to 0, n times q has to be greater than or equal to 0. So the p should be the population proportion, which is your null hypothesis, should be the same as the null hypothesis. Okay, third step is set up a sample distribution of proportion and find the test statistic. So the sample distribution mu p hat is equals to the same one that you got from the null hypothesis, and sigma p hat is equals to p times q over n. That's the sampling distribution proportion, and the z-score, which is the test statistic, equal to p hat, which is the sample proportion, subtracting the null hypothesis proportion, divided by p q over n. Okay, I'm going to use a 0 for that. And then remember that this p hat is going to follow a normal distribution with mu hat, sigma p hat, and this z-score follow a normal distribution with mean equals to 0, sigma equals to 1. And find the p-value. So if p-value is small, that means less than alpha, we will reject the null hypothesis. And if p-value is not small, that means it's greater than the significant level that we choose. That means there's not enough evidence. We will fail to reject the null hypothesis. That means not enough evidence for the alternative hypothesis. All right, so here, and then you will write down your conclusion. What is your evidence, the detailed evidence for the null hypothesis and the alternative hypothesis. All right, here, a current antacid provided 70% relief for, and 70% people who use it and feels that they got relief. If a pharmaceutical company has a new drug and they want to test if it's more effective. All right, so now we can start it. Our null hypothesis should be something that already happening. The current status is 17%. And the alternative hypothesis is what is more effective. So that means the null hypothesis is something that greater than 70%. Now with central limit theorem, independence, check, randomization, check, success failure condition. We haven't checked yet. So now, first of all, look at the sample size. How many people that they're sampling? 100 people, right? So that means the sample size equals to 100. And m times p equals to, remember that when we check in the success and failure condition, we use the null hypothesis one. So it's 100 times 0.7, which is equal to 70, greater than or equal to 10. M times Q equals to 100 times 0.3, which is greater than or equal to Q. So that means the success and failure condition check. Okay, set up a sampling distribution of proportion. Okay, our mu hat is equal to our null hypothesis, which is P, which is 0.7, sigma P hat equals to P times Q over N, which is 0.7 times 0.3 divided by 100, take square root. So this is equal to 0.048458. Okay, next is test statistic. Well, test statistic. Z equals to P hat subtract mu P and sigma P hat. All right, so P hat is equal to what? P hat is the sampling proportion, the sample proportion. Okay, now let's take a look at our sample. We're sampling 100 people, and 75% people experience relief. So that means our sample proportion is 75 people out of 100 people, which is 0.075. So our test statistic is equals to 0.75 minus 0.7 divided by 0.0458. So by calculator, I have 1.917. Now calculate the p-value. If we use a GeoGebra, we're trying to calculate the probability of p greater than, because it's more effective, 0.75, because that's our p hat. It's a right tail test, so it's greater than 0.75. So what you are looking at on statistics GeoGebra, this is 0.7, one standard deviation is 0.7485, and here is approximately 0.8. So you are expecting p hat is somewhat in here, right? Greater than here, a little bit over one standard deviation. This part is going to be your p-value on your GeoGebra. Now let's take a look. Point 0.7 and sigma is and we want x is greater than, so it should be on this side, 0.75. So we got 0.1375. So our p-value is 0.1375. Now we need to look at the test statistic. So for test statistic, we know that this is follow a normal distribution, 0 and 1. We want to find out the probability that the z-score greater than 1.917 is equal to what with a test statistic. So mu equals to 1, sigma equals to 1, mu equals to 0, sigma equals to 1. And this is 1.917. So it's the same. You got the same p-value, which is 13.75%. So I got, that's our p-value. So what is going to be our conclusion? So conclusion is something that we need to compare that to our significant level, which is our alpha. So our p-value by calculation, we have p-value equals to 13.75%. If they didn't give you an alpha, the default one is 5%. Our p-value is greater than alpha, which is not small enough. So in that case, we fail to reject the null hypothesis. So that means there's not enough evidence, for what is that we're trying to prove that the drug is more effective. So that should be your conclusion. And also you should mention the p-value. Fail to reject a null hypothesis. This part is important. With p-value equals to 0.1375. Mention p-value, please. Okay, so that's it for the conclusion. Now let's try another examples. So let's look for another examples. A company developed what is hoped to be better instruction for its customers set up their smartphone. Their goal is to have 96% of the customers succeed. The company tested the new system on 400 people, of whom 373 were successful. Is this wrong evidence that the new system failed to meet the new company's goal? All right, so what is the null hypothesis? That's our step 1 to determine our null and alternative hypothesis. The null hypothesis is the current, what we want, something like that. So the null hypothesis is P equals to 96%. And they hope it will be better. So that means better means more. They want it to be more than 96% of customers succeed. Okay, step 2 is the central limit theorem, because without that, we can't have our sampling distribution of proportion set up. Okay, so each customer, they're independent, and the customer they found must be randomization. Now it's the success and failure. So failure condition. Okay, M times P. Well, they sampling 400 people, right? P, we're going to use the null hypothesis, 96. This has to be greater than 10. And then 400 times 0.94, which is our Q, also greater than 10. So that means, yes, we meet the central limit theorem. Okay, the third step is our sampling distribution of proportion. All right, so our mu of p hat equals to our null hypothesis, which is 0.96. Sigma p hat is equals to square root of p times q over our sample size divided by 400. So when you calculate that, this is 0.009798. I can approximate it to 0.001. So that means you expected the normal distribution look like this. At 1 standard deviation, 2 standard deviation, and 3 standard deviation. And all right, so what's our p hat? Well, p hat is the sample proportion. Let's find out. So our p hat should be what would be the sample result look like. Our p hat is 376 people over 400, because that's the success rate. So p hat is equals to 0.94. Well, that's not better. That looks like less than what they expected, less than their goal. So you're expecting the p hat is in here, right? So your p value is on this side. All right, so that is sampling distribution of proportion. Well, after that, we also need to do the test statistic. So for test statistic, we want to find the z-score, which is our p hat, subtract our mu p and sigma p hat, which is 0.94 minus 0.96, and our sigma is 1%. So this is negative 2.0412. And the z follow a normal distribution with 0 and 1. So that means I am looking at something 0, 1, negative 1, negative 2, negative 3, and negative 2.1 is something in here. That should be your p-value. All right, so you can either use one of these to find out your p-value. So the next step should be, I can go back, but you saw the video, you can look back. The red part is the z statistic. Okay, so the next step is step 4. We want to use GeoGebra to find the p-value. Either one should work the same when you use GeoGebra. So I'm going to use the z-score one. We want the z-score less than negative 2.412, statistic less than negative 2.014012. So it's 2.06%. So our p-value is equals to 0.0206. So the next step is we compare the p-value and the conclusion. So since our p-value equals to 2.06%, alpha equals to 5%. If they didn't say the significant level, we just use alpha equals to 5%, and the p-value is less than alpha, then we can say this is a significant small. So we will reject the null hypothesis, and with a p-value is 0.0206, and there is evidence that the alternative, something we're trying to prove, that the new system failed to meet the complaint goal. Okay, that's it. Here's an example on all the very detailed example on showing you how to prove a hypothesis test.